All right, so let us try to look through some more practices regarding U substitution. All right, so the first one here we have integration of dx over 5 minus 3x. So what would you set U as? In this case, if you set U as 5 minus 3x, then we get to realize that du over dx simply becomes negative 3. Now, therefore, we can write down du as negative 3 dx by multiplying by dx on each side. But when you look at the expression, we don't have negative 3 dx. We only have dx alone. So what we like to do is let us divide each side by negative 3. So that we have dx by itself. Then I think we are almost ready here to perform the substitution. So integration of, in place of dx, we have du over negative 3. And in place of 5 minus 3x, we have 1 over u, because u replaces that. Now, just for the simplicity sake, well, we can bring out the factor of negative 1/3, or 1 over rather, negative 1/3 to the front, or negative 1/3 to the front. Then we'll end up getting 1 over u du. Then integration of that becomes negative 1/3, and integration of 1 over u becomes ln of u plus c, which ultimately becomes negative 1 over 3 ln of, in place of a u, we can put 5 minus 3x plus c. Now, the one thing that which you have to realize is this. You see 5 minus 3x sometimes could be negative values based upon the x. So what we want to do is we want to restrict this one by putting the absolute value sign. Then we realize that this will always be defined as long as the within the absolute value doesn't become 0. All right, let us move on to the next question. Here we have, in this case, yes, we can set u as e to the x. Because when we are looking into this, what we have to do is, hey, whatever I set u as, can I see part of its derivative on the other part of the expression? If I can see that, then that is what our u could be. So derivative of e to the x is still e to the x, which allows us to say, hey, du is equal to e to the x dx. But in this case, we see this one clearly from here. Therefore, what we can say is this is equal to sine of u, replacing e to the x, and simply du. Then antiderivative of sine of u becomes negative cosine of u plus c. Now u being the e to the x, by plugging them in, we end up getting negative cosine of e to the x plus c. All right, let us move on to number 15. Here we have sine of pi t. Now, in this case, since if you have to set pi t as u, then what we end up getting is du over dx, or du over dt in this case rather, simply becomes pi. Now, to have du by itself, we end up getting du equals pi dt. Now, we don't see pi outside of the sine expression, so what we end up getting is we could divide each side by pi. Now then pi cancels out. We only have dx, and so is dx here. Then I think we are ready to substitute. Here we have sine of pi t becomes simply sine of u, and in place of dt, we have d over pi. Now, then, for simplicity's sake, we can bring out 1 over pi to the front. Any constant, we can bring them to the front. And sine of u du. Now, what is the antiderivative of sine of u? Becomes negative cosine of u plus c. Now, Then here we have negative 1 over pi, and cosine of u simply becomes pi t, and then plus c. That's what we end up getting. All right, let us move on to number 16 here. All right, so here we have, notice that if you have to set x squared plus 1 as u, then derivative will become 2x. You see the part of 2x, which is x over here, on the numerator. So this will be a good sign for us to have u as x squared plus 1. Now, then du over dx becomes 2x. Therefore, which makes du as 2x dx. Now, when you look into this one, you'll notice that we don't have 2x dx, we only have x dx. So therefore, we can divide each side by 2. Then we have x dx left, which will be equivalent to d over 2. So let us express this one more time then. 1 over, in place of this, we could put du, and we have du over 2. Now, then you will see that everything is in terms of u. Now, so taking away 1/2 the front, and we end up having 1 over u, du, and same as before. 1/2 then ln of u plus c. Now, but in this case, we end up having 1/2 ln of, in place of u, we could plug in x squared plus 1 plus c. Now, as you can see, x squared plus 1 will never be negative, so we don't have to worry about the absolute value, and then it can be done. All right, let us move on for the next. Here we have, it looks somewhat complicated, but let us look at it carefully. Do you notice that what if this one wants to be u? 3ax plus bx cubed. Then du over dx becomes simply 3a, and then plus 3bx. Now, then notice that this one looks somewhat similar to this one, except the factor of 3. So in fact, what we end up getting is this, du over 3, I'm skipping one step here, is equal to a plus bx squared whole thing times dx, which we get to see right over here. Now, then if you have to rewrite this one, what we end up getting is this integral of 1 over square root of u, because u replacing that with the inside value, and we'll end up having du over 3. Now, bringing 1/3 to the front, as we have done earlier. And here we can rewrite this one as u to the negative 1/2 power, and du. Then we can easily see that 1/3 and u to the 1/2 power over 1/2 by the inverse or reverse of power rule, and plus c. We can put c here inside or outside, it doesn't really matter at this point, which will simplify into 2/3. Now in place of u, we're going to put original expression, and since 1/2 as an exponent is radical, so we end up getting 3a x plus b x to the 3rd power, an entire thing after that plus c. That becomes our answer. All right, let us move on to number 18. Here, in fact, we can look into this one. Wait a minute, secant and then tangent. That's right. If you set u as 2 theta, then we get to realize that the u is in fact equal to 2 d theta. Now, once again, we only have d theta, so what we end up getting is du over 2 must be equal to d theta. Then we get to realize that this must be equal to secant of u times tangent of u and du over 2. Now, if you have to rewrite this one, we end up getting 1/2 secant of u, tangent of u, and du. But what is secant tangent? That's right. It is in fact a derivative of secant u plus c. Now then it becomes 1/2 secant u in this case was 2 theta, and plus c becomes our final answer. Alright, number 19. Wait a minute. That's right. If you assume u as ln of x, then its derivative becomes 1 over x, as you can see. So if you said u equals ln of x, then here we get to realize du equal the derivative of this, which is 1 over x, and then just by multiplying by dx, that's what we end up getting. And notice that we do have this in this part of the expression. Now, so therefore what we end up getting is this is equal to u squared du. Then we change that in u to the third power over 3 plus c. Now, then since u was ln of x, we will end up having, in fact, ln of x to the third power plus c. That becomes our final answer. Alright, let us move on to number 20. Here we have a and b are the constants. So here if you have to set u as ax plus b. Now, then du becomes simply a dx. Now we don't have a here, so we end up dividing it by a from both sides. And we end up getting dx must be du over a. Now, then if you have to put all these things together, we'll end up having 1 over u and du over a. Once again, 1 over a is brought to the front. Then we have 1 over u du. That's what we end up having. Now 1 over a is there. Now integration of 1 over u, as you know, that's ln of u plus c. Now since u is equal to ax plus b, we're going to have 1 over a times ln of absolute value, just to make sure that the inside values are positive. Ax plus b plus c. Right, that becomes our final answer. Alright, number 21. How about this? Yes, that's right. If you set u as square root of t, then you might be wondering, hey, wait a minute, we have 2 square root of t's here. Which one will be our u? I believe that would become more clearer once we take the derivative. Du over dt, this one we'll do step by step. And it becomes, since this t is equal to t to the 1/2 power, what's going to be happening is 1/2 will come out to the front, and then t to the negative 1/2 power. In other words, this is equal to 1 over 2 square root of t. Now, then of course, if you multiply by dt on both sides, then we get 1 over 2 square root of t dt, which looks very similar to here, except 2. So if you multiply by 2 on each side, then we get 2 du. That's right, 2 du must be equal to 1 over square root of t dt. So by putting everything in, we'll end up getting cosine of u n times 2 du. Which will be equal to 2 cosine of u du. Now when you take the antiderivative of that, then we end up getting 2 sine of u plus c. Obviously u was the square root of t, then we end up getting 2 sine of square root of t plus c. Alright, let us move on to number 22. Now here it looks somewhat difficult, but if you take the inside, this one as the u, then I'm hoping that we'll be able to see nice connection to the question. If you said u as 1 plus x to the 3 over 2 power, then the u simply becomes 3 over 2 and x to the 1/2 power. Notice that this times the x here, x to the 1/2 power is what we have. So if you have to multiply both sides by 2/3, the u then becomes square root of x dx. Alright, then let us try to put everything in together. So we have integral of 2/3, I'm just going to bring it to the front, 2/3, and sine of u and du. Then here we have 2/3. Antiderivative of sine becomes negative cosine of u plus c. Now, u, in fact, is this expression, we end up getting 2/3, negative 2/3 cosine of 1 plus x to the 3 over 2 power plus c. That's our final answer. All right, let us move on to a couple more questions here. Here, yes, you can easily see that. If you set sine of theta as u, then the u, in fact, becomes cosine theta d theta. And we see that clearly over here. Then in this case, what we end up getting is sine the 6th power of u. Oh, my bad. Not that. Sorry. Instead of, since sine theta is u, so we will end up having u to the 6th power and du. Then our next step becomes u to the 7th power over 7 plus c becomes our intermediate result. Since u is equal to sine theta, we end up getting sine to the 7th power theta over 7 plus c becomes our final answer. Right, number 24. Here, secant square outside, tangent inside. I think this is a signal that tells us, hey, maybe you can set u as tangent theta. Then we get to realize that the u is equal to secant square theta d theta. Then we see that right over here. So therefore, in fact, we can even put it as a plus 1 here, having whole entirely inside as the u. Then we'll have the same expression. So therefore, we end up having integral of u to the 5th power du. Then this becomes u to the 6th power over 6 plus c, which finalized to 1 plus tangent theta to the 6th power over 6 plus c becomes our final answer for number 24. All right, so we'll stop for now, and I'll see you soon. Have a nice day. Bye-bye.